This video is going to look at Pythagorean's theorem or the side-side relationship for a right triangle. Before we move into the theorem, a couple calculations that we need to be able to do. And if we can do these things, we can do Pythagorean theorem. So calculate the value of 5 squared, 8 squared, 10 squared, 2.7 squared. Remember, when you square something, like 5 squared, it's 5 times 5, not 5 times 2. Most scientific calculators have this button, x squared. So all I would do on my calculator is type 5 and then hit that button. So 5 squared, and you get that is 25. 8 squared, same thing. Type 8, hit your x squared button, and you get that that's 64. 10 squared, okay, 10, hit that button, or hopefully you can do these in your head without a calculator. You get 100. 2.7, that one we need the calculator for probably. You would get 7.29. Right? So just remember, when you're squaring something, it's not a times 2. Okay. And then down below, it's a little bit different. I want to know, or what I'm told in the first one is x squared equals 9. So basically some number squared is 9. What number, when you square it, is 9? Like 1 squared would be 1, 2 squared would be 4. Oh, 3 squared. Right? 3 squared is 9, so x is 3. Similar on the next one. What number squared is 36? Well, you might think, okay, 5 squared is 25. Oh, 6 times 6 is 36. So that means 6 squared is 36. X would be 6. Some of those numbers we might be able to see and get the answer right away. 87 is going to be harder. So there is something on our calculators that we can do. If I have x squared and I just want x, what I can do is I can square root. That symbol right there is called the square root function, and I could square root the 9. And if you look on your calculator and you do the square root of 9, hit equals, you get 3. Same thing here. X squared is 36. That means x is the square root of that. X squared is 87. That means x is the square root of 87. And if you go ahead and type that into your calculator, you're going to get a decimal. So I need to round approximately 9.3. X is the square root of 56. I'm going to have to round that one too. About 7.5. My calculator said 7.48, so it rounds up. Those are some of the skills that we need to know. We can skip that. So, like I said before, I often call it the Pythagorean Theorem. It is also known as the side length formula. Pythagoras often gets named for this theorem, so that's why I still call it Pythagorean Theorem. That's how I learned it. But more recent evidence has shown that the Egyptians and the Babylonians actually knew about this relationship before him. So maybe he didn't invent it. So side length formula, Pythagorean theorem, it's kind of the same thing. Basically, it can be used when you have a right triangle. A right triangle is when you have a 90-degree angle. And what the formula is it's this guy here. A squared plus b squared equals c squared. What does that mean? Well, A and B are the two legs. So basically this formula is telling me that if I take that side A and I make a square out of it, right, A squared, and then I make a square here, that's B squared. Right, so A and B are the legs. The legs will always make the 90-degree angle. They will connect. the formula says that those two squares, if I add them together, will equal the same size as the square on the hypotenuse. Okay. So that's kind of like a visual, but that's the formula that we'll need. Okay. So let's go and let's try some of these. First example. Okay. I've got this triangle. Careful how they are labeled, right? A is labeled there. That doesn't necessarily mean that it's A in the formulas. So the formula is a squared plus b squared equals c squared. The important thing is that A and B are the legs. The A and B are the sides that make 90 degrees. The sides that make 90 degrees are these two, 8 and 15. So 8 squared plus 15 squared, and c squared is always the hypotenuse. The hypotenuse is always across from that box. So here's the right angle. Opposite the right angle is the hypotenuse. Here I don't know what the hypotenuse is, but it's labeled an A. So I'm just going to say equals a squared. Okay. Now I just go to my calculator. We practiced this already. 8 squared, 64. 15 squared, 225. Okay. Technically here I just have an equation, so what I want to do is simplify it and solve for A. I can add those two numbers, 64 and 225 equal 289. And now we just practice this. I have a squared. I just want to know what a is. So to get rid of this squaring, I can square root the other side. So you go to your calculator, you square root 289, and you get that a is 17. Be careful here. There's actually some units there. So I'm okay if you just kind of sneak it in here. If you get 17, just write centimeters there. That's it. All right. So B, Pythagorean Theorem. So what are the A's and the B's? Well, remember A and B are the legs. So they're going to be those two sides. The hypotenuse, the C, is going to be opposite it. So when I go to Pythagorean Theorem, the legs, the A and the 15, those go together. So a squared plus 15 squared equals the hypotenuse squared. The hypotenuse here is 17. Okay. All right. Well, now I can square some numbers just like we did last time. Now the difference here is, well, I guess the similarity here is I'm still trying to find this unknown. I need to get this by itself. So I need to do a little bit of algebra because right now the a squared has a plus 225. I want to get rid of the plus 225. And remember to do that, I can move it over the equal sign and do the opposite, minus it. So that pink step, that pink arrow, that is a new thing. Sorry, that's different than the last one. It's not a new thing. You've done that in the algebra this year. A squared is 64. I don't want to know what a squared is. I just want a. So I need to square root the 64. When I do that, I get a is 8. And then put your units there. Okay. Some of you guys, I know you might rearrange this formula and say something like a squared equals c squared minus b squared. Awesome. Go ahead and do that. Okay. Let's do a couple more here. So Pythagorean theorem, a squared plus b squared equals c squared. A and b are these two sides. C is over here. So when I go to Pythagorean's theorem, or the side length relationship, A and B are 5 and 12. 5 squared plus 12 squared equals the hypotenuse. I don't know what that is, so you can use any letter you want. Oftentimes in math we use an X. Now I can square these. Those numbers are together, so I'm just going to go ahead and add 25 and 144. And as soon as I get down to here and I have something squared equaling the number, I can get rid of that square by square rooting the other side. Right? It's kind of like the inverse. Like if I move something that's adding over, I subtract it. If I move a square over, I square root. And I will get 13 meters for X. Another example. So I'm going to start Pythagorean's theorem. A squared plus b squared equals c squared. You want to think about what are the legs. These two are the legs, so they'll stay together in my formula. A squared might be 6 squared. B, I don't know. That's an X. So I'm just going to write X squared equals the hypotenuse squared. C is always the hypotenuse. So 20 squared. I'm going to square these values. And now my goal is to solve and see, like, what is X? So I want to get rid of what's with it. I want to get rid of that 36. So I'm going to move it over. And when I move it over, I minus it. I still have the X squared and the 400, but that 36 becomes a subtraction. And now I get rid of the square. So I can square root the other side. And I'm going to have to round, so put a dot on the line, about 19.1 centimeters. So that's how it works. And then, like, basically this might be applied into some other problems. So a first word problem looks at TVs. School is getting a new TV that's 144 centimeters wide and the diagonal is 165 centimeters. Most often when you buy TVs and it says it's a 70-inch TV, that actually talks about the diagonal length, this length here. But what you want to make sure is, like, you have enough height wherever you're going to put the TV. If you're putting it on a shelf or a mantle, you want to make sure that there's enough space for it. So without a picture, questions can get hard. So the easiest thing to do is just, like, sketch out what we know. Here's my TV. It's 144 centimeters wide, and the diagonal, that's this. The diagonal is 165. How tall is the TV? This is what I want to try to solve for. Well, I can use Pythagorean's theorem. Which sides are the legs? Well, here's the 90-degree angle. So that means those are sides A and B. It would go X squared plus 144 squared. And the hypotenuse is that diagonal, the 165. Oops, plus 20,736, and then 165 squared is 27,225. I want to move that over, right? I want to solve for X, so I got to get it by itself. When I move it over, I need to subtract it. We've been doing this for a fair bit and a little while in math, so if you want to, you can do that subtraction and just write this, right? If you aren't sure, then you could have a line where you say 27,225 minus 27,736. You can absolutely do that. You don't need to do that, Why is my eraser so big? You don't need to do that, but you can. Get rid of the square. So I can square root the other side. And now I found out that the TV is about 81 centimeters tall. Be careful. It says round your answer to the nearest centimeter. So the nearest whole centimeter. Because it's a word problem, you would just want a quick word answer. Therefore, the TV is 81 centimeters tall. If you don't round here, that is okay as long as in your sentence, then you round to the nearest whole. Okay, and that's just another solution. Next question, calculate the area of a right triangle. So here I want to find the area of the triangle on the toy sailboat. Okay, well, area of a triangle, right? We're given that formula, it's down below, it's on our formula sheet. Area is base times height divided by 2. When I look at this now, remember base and height, like the height is always perpendicular to the base. So those are my base and my height. I don't know what the base is. I know the height of the triangle is an 8. So it's going to be the base times 8 divided by 2. I have to figure out what is that base. If you look, that triangle is a right triangle. Right? So I can use Pythagorean's theorem to find that bottom side, to find the third side. Those two sides, the base and the height, that's actually the legs of the triangle. So I could say a squared plus 8 squared equals 11 squared, right? The hypotenuse is 11. A and 8 are the legs, so they stay together. A squared plus 64 is 121. Move the 64 over and subtract it. 121 minus 64 is 57. Square root the 57 and you get about 7.5 centimeters. So the base, that base there, is 7.5. Now I can calculate the area of the triangle. And you will get 30 centimeters squared. Therefore, the area of the triangle of the sailboat is 30 centimeters squared. This idea here, where Pythagorean theorem snuck into a question, that is going to happen on your area questions on the unit test. Yesterday and yesterday's homework it didn't, because it was a review of everything previously, but this year you will have a lot of Pythagorean theorem in the future questions as we go through this unit. It's going to sneak in a lot. Okay, so make sure you ask questions if you have them. This question here, you're going to have something similar in the homework, and this is a challenging question, just because like students hadn't seen it. So I wanted to add it this year just to help you, because you do have all the skills needed to do this. If I look at this, I have a right triangle. These are the two legs of the right triangle. So there's the A and the B, but they're the same length. So if one side is 5 centimeters, the other one is 5. If one is 10, the other one is 10. I don't know what they are, so I'm going to say this side would be X centimeters. That means the bottom is also X centimeters. If I use Pythagorean theorem, okay, well, A and B are both X. So I can say X squared plus X squared equals, Why does that look funny? Equals the hypotenuse squared. Think back to the algebra. 1x squared plus another x squared means I have 2x squareds. On the other side, 20 squared is 400. Now I still have an equation I need to solve. I want to get x by itself. So first I want to get rid of that 2. And how I do that, because it's being multiplied, I'm going to divide it out. Now I have x squared is 200. Get rid of the square by square rooting. And just got to jump on my calculator. The square root of 200 is approximately 14.1 centimeters. So you will see a question like that in the homework. Hopefully that can help you problem solve your way through it.